Most people watching a car rebuild video like this expect something simple and familiar. They think they will see a broken car, some tools, a garage, and a creator slowly bringing the vehicle back to life step by step. That is the normal pattern on YouTube. It is what viewers are used to seeing, especially in car content. A wrecked supercar comes in, the damage is shown, parts are replaced, and in the end, the car starts again. It feels satisfying, predictable, and safe. But what is happening with Mat Armstrong and this Bugatti project is not following that normal pattern at all. From the outside, it might still look like just another rebuild video, but the deeper you go into the process, the more you realize something much bigger is taking shape. This is not just about fixing a damaged hypercar. It is about challenging a system that has existed for years without serious interruption. It is about what happens when someone tries to repair one of the most complex machines ever built without following the usual rules set by the manufacturer. The interesting part is that the real story is not only in the car itself, but in everything around it. The rules, the restrictions, the hidden systems, and the limits that are usually invisible to normal owners. Mat's project slowly reveals that owning and repairing a hypercar is not as simple as it looks from the outside. It is not just a machine you buy and fix like a regular vehicle. It is part of a tightly controlled world where almost every major repair decision leads back to one place: the manufacturer. And that is where this story becomes different from anything we usually see online. To understand why this project is so unusual, you first have to understand how hypercar ownership normally works. When someone buys a car like a Bugatti, they are not just buying a vehicle. They are entering a very controlled system. Everything about the car is designed, monitored, and supported in a very specific way. Unlike normal cars, where you can go to different mechanics, use aftermarket parts, or even repair things yourself if you have enough skill, hypercars do not work like that. In this world, almost every problem eventually leads back to the original manufacturer. If something breaks, it is not simply about finding a replacement part or asking a local workshop to fix it. In most cases, the owner is expected to go back to the official service network. That means returning to the company that built the car in the first place. There are many reasons for this system. These cars are extremely complex, built with very tight engineering limits, and often require special tools and software that are not available to the public. Even small mistakes in repair can cause serious problems because the parts are not designed with flexibility in mind. Everything is built to exact measurements, often down to very tiny levels of precision. This creates a situation where independent repair becomes very difficult, almost impossible in many cases. Over time, this has created a kind of closed system where ownership is not fully independent. The car belongs to the owner legally, but the ability to repair it freely is limited. This is the background that makes Mat Armstrong's project so interesting. He is stepping into a system that has remained mostly untouched for years and trying to operate outside its normal boundaries. That alone makes the situation unusual because it raises a question that has not been seriously challenged before in this space. What happens when someone tries to fully rebuild a hypercar without depending completely on the manufacturer? The reason this system exists is not random. It is deeply connected to how hypercars are engineered. A vehicle like a Bugatti is not built like a normal car. Every part is designed with extreme precision and tested under very strict conditions. The engines, transmissions, electronics, and even the smallest mechanical components are built to work together as one highly synchronized system. There is very little room for error. In many cases, parts are not interchangeable with anything else on the market. They are custom-made for that exact model and often for that exact production series. This level of engineering makes the car incredibly powerful and fast, but it also makes it very fragile when it comes to repairs. Even a small mismatch in parts or incorrect installation can create serious performance or safety issues. Because of this, manufacturers keep very tight control over repair information and tools. Diagnostic systems are often locked behind official equipment. Software updates, calibration tools, and repair procedures are usually only available through authorized service centers. This creates a situation where even highly skilled independent mechanics cannot easily access the information needed to repair the car correctly. On top of that, sourcing parts is another major challenge. Unlike normal vehicles, you cannot simply order parts from multiple suppliers or aftermarket companies. Many components are restricted, limited, or only available through official channels. Some parts may come from donor vehicles or special approved sources, but these are not easy to find or use. All of this combines into a system where repair is not just a technical task, but also a logistical challenge. It requires access, permission, and resources that most independent builders do not have. This is the environment that Mat Armstrong is stepping into, and it explains why his project is not just about fixing a car, but about navigating an entire system built around control and precision. What makes Mat Armstrong's situation so different is not just the car he is working on, but the way he is approaching the rebuild itself. Instead of treating it like a normal restoration, he is documenting and attempting to solve problems that usually stay hidden inside official workshops. The car he is working on is heavily damaged, which already makes the repair process difficult. But the bigger challenge is everything surrounding the repair. Every time he reaches a step that seems simple on the surface, a new limitation appears. A part that cannot be sourced easily. A system that requires special access. A component that only works with manufacturer-level tools. These challenges stack on top of each other and turn what looks like a straightforward rebuild into a much more complex project. What is important here is that he is not working inside the official system. He does not have direct access to factory tools or engineering teams. Instead, he is relying on creativity, problem-solving, and available resources in the independent world. This makes the process slower and more uncertain, but also more interesting from a viewer's perspective. Every small success feels meaningful because it happens outside the normal boundaries of hypercar repair. At the same time, every obstacle highlights how restricted the system really is. The rebuild becomes less about just fixing metal and machinery and more about testing whether it is even possible to fully restore such a car without official support. This is what makes the project feel different from typical car content. It is not just a transformation story. It is a real-time experiment in independence versus control in the automotive world. As the project continues, it raises a bigger question that goes beyond just one car or one creator. It starts to challenge how we think about ownership in high-performance vehicles. If someone buys a hypercar, should they have full freedom to repair it however they want, or should the manufacturer maintain strict control over how it is maintained? On one side, manufacturers argue that this level of control is necessary because of how complex these machines are. They believe only trained technicians with proper tools can ensure safety and performance. On the other side, creators like Mat Armstrong show that independent builders are capable of solving problems in creative ways, even when official systems are not available. This tension between control and freedom is becoming more visible as more people document repairs online. What used to be private, hidden processes inside service centers are now being shown to millions of viewers. That changes the conversation completely. It brings transparency to an area that was once very closed. It also raises awareness about how limited independent repair options really are in the hypercar world. In the end, this is what makes the story so powerful. It is not just about a damaged Bugatti being rebuilt. It is about what that rebuild represents. It is about questioning systems that have existed for decades without challenge. And it is about whether those systems can remain the same in a world where information, tools, and skills are becoming more widely shared than ever before. As the rebuild moves forward, the reality of working on a hypercar like this becomes even clearer. Every step in the process is slower than expected, not because the work itself is impossible, but because everything around it adds delay and complexity. Even finding basic information can take time because there is no open guide that explains how every part of the car is supposed to come apart or go back together. In normal car repairs, mechanics often rely on manuals, online guides, shared knowledge, and aftermarket support. But in this case, most of that does not exist in a usable form. This means a lot of decisions have to be made through trial, observation, and careful testing. One small mistake can lead to more damage or create problems that are even harder to fix later. That is why every move in the garage carries more weight than it would in a normal rebuild. At the same time, there is a constant search for parts, tools, and solutions. Sometimes a part is available only through rare channels, sometimes it has to come from a donor vehicle, and sometimes it requires custom work just to make it usable again. This is not a simple replacement process. It is closer to assembling a puzzle where many pieces were never meant to be taken apart in the first place. And because this is being documented, the audience gets to see not only the progress, but also the frustration, the delays, and the problem-solving that happens behind the scenes. This makes the rebuild feel more real, because it is not polished or simplified. It shows the true nature of working on something that was originally designed to stay within controlled environments. The garage becomes more than just a workspace. It becomes a place where limits are constantly tested, where assumptions about what is possible are challenged, and where every small breakthrough feels earned rather than expected. This slow and difficult process is exactly what makes the project stand out, because it shows that even with skill and determination, some systems are designed in a way that naturally resists independent repair. Another important layer of this story is the way knowledge itself is controlled in the hypercar world. In most industries, repair knowledge spreads over time. Mechanics share information, enthusiasts document solutions, and online communities help each other solve problems. This creates a growing pool of shared understanding that makes repairs easier for everyone. But in the case of hypercars, that flow of information is much more limited. A large amount of technical knowledge is kept within manufacturer networks, meaning it does not fully reach the public. This includes detailed diagnostic procedures, software tools, and precise repair instructions. Without this information, independent builders are forced to rely on experience, experimentation, and partial data gathered from different sources. This creates a gap between what is officially known and what is practically possible outside the system. Mat Armstrong's project exposes this gap in a very visible way. As he works through each stage of the rebuild, it becomes clear that solving problems is not just about skill, but also about access to information. Even experienced builders can hit a wall when they do not have the correct data or tools. This is where creativity becomes important. Instead of following exact instructions, solutions have to be adapted, adjusted, and sometimes completely reimagined. This makes the process unpredictable but also interesting because it shows how much can still be achieved even when formal systems are missing. At the same time, it highlights how dependent modern hypercars are on controlled ecosystems. These cars are not just machines. They are part of a larger network of software, diagnostics, and proprietary systems that are not easily separated from the manufacturer. This raises deeper questions about how future vehicles will be designed. If more cars become like this, will independent repair still be possible in the same way? Or will ownership gradually shift into something more restricted, where even skilled individuals cannot fully operate outside official channels? The rebuild becomes a real example of this question in action, showing both the possibilities and the limitations of working outside the system. As the project continues to gain attention, it also changes the way people view hypercar ownership in general. What once felt like a distant and exclusive world begins to feel more visible and open to discussion. Viewers who normally only see finished, polished supercars now get a look at what happens when things go wrong. This shift is important because it breaks the illusion that these machines are untouchable or perfectly maintained at all times. Instead, it shows that even the most advanced cars in the world can end up damaged, disassembled, and sitting in a garage waiting for solutions. The difference is in how those problems are handled. In the traditional system, most of this work happens behind closed doors in official facilities. The owner never sees the complexity involved in repairs. But in this case, the process is public, and that changes everything. It creates a learning experience not just for the builder, but also for the audience watching. People begin to understand that owning a hypercar is not just about speed, luxury, or status. It also involves responsibility, limitations, and dependence on systems that are not always visible at the time of purchase. At the same time, it shows how determined individuals can push against those limits. Even without full factory support, progress is still possible, even if it is slow and difficult. This balance between restriction and creativity is what makes the story compelling. It is not about proving that manufacturers are wrong or that independent builders are always better. Instead, it is about showing that the reality is more complex than it first appears. There are strengths and weaknesses on both sides, and projects like this bring those differences into focus in a way that is easy to understand. In the end, the rebuild is not just about restoring a car. It becomes a window into a much larger conversation about control, access, and the future of how complex machines will be repaired and maintained in a world that is changing quickly. As more progress is made on the Bugatti rebuild, the difficulty of the project starts to shift from just physical repair into something more mental and strategic. At this stage, it is no longer only about replacing damaged parts or fixing visible problems. It becomes about understanding how all the systems inside the car are connected and how one small decision can affect many other areas. Hypercars are built with layers of tightly integrated systems where mechanical, electrical, and digital components all depend on each other. This means that solving one issue often reveals another hidden problem that was not obvious before. A simple repair can suddenly turn into a chain of new challenges. For someone working outside the official manufacturer environment, this makes the process even more complicated. Without direct access to factory diagnostics or internal software tools, each step requires careful testing and a lot of trial and observation.